Welcome to another Geography 215 math video. This math video will be about Chapter 4. The learning objectives for this video are to learn about temperature conversions, to learn about heating degree days, to learn about the Bowen ratio, and to learn about heat energy. Let's start with temperature conversions. There are three measurements of temperature that we use in meteorology. That is Fahrenheit, Celsius, and Kelvin. This table shows how the temperatures are converted. Let's work on some temperature conversion problems. The first problem consists of 32 degrees Fahrenheit. What does that equal in Celsius and in Kelvin? First, you will want to take the Celsius conversion because you have Fahrenheit. Taking the Celsius conversion, you'll want to plug 32 degrees Fahrenheit into the equation. This gives you degrees Celsius equals 5/9 times 32 degrees Fahrenheit minus 32, which gives you degrees Celsius equals 5/9 times 0, which means Celsius equals 0. Now, since we have Celsius, we can convert to Kelvin. The Kelvin equation is listed on this slide. Taking the Kelvin equation, you'll want to plug in 0 for Celsius. So you get Kelvin equals 0 degrees Celsius plus 273.15, which means Kelvin equals 273.15. We have finished the first problem. Now let's move on to the second problem. For the second problem, we have negative 40 degrees Fahrenheit. What does that equal in degrees Celsius and in Kelvin? First, we'll want to take the degrees Celsius equation. So we have degrees Celsius equals 5/9 times degrees Fahrenheit minus 32. So plug in negative 40 degrees Fahrenheit into the problem. So now we have degrees Celsius equals 5/9 times negative 40 degrees Fahrenheit minus 32. That gives you degrees Celsius equals 5/9 times negative 72. That will equal negative 40. Now that we have degrees Celsius, we can solve for Kelvin. Remember, Kelvin equals degrees Celsius plus 273.15. So plug in negative 40 degrees Celsius into the equation. We get Kelvin equals negative 40 degrees Celsius plus 273.15. That means Kelvin equals 233.15. Now let's move on to the third problem, where you have a degrees Celsius to convert. The question asks 32 degrees Celsius equals what degrees Fahrenheit and what degrees Kelvin? Since we have degrees Celsius, we can use a Fahrenheit equation. Degrees Fahrenheit equals 9/5 times degrees Celsius plus 32. So plug in the 32 for degrees Celsius and you get degrees Fahrenheit equals 9/5 times 32 plus 32. That gives you degrees Fahrenheit equals 57.6 plus 32, which in the end gives you a degrees Fahrenheit of 89.6. Now we can use the Kelvin equation. Again, Kelvin equals degrees Celsius plus 273.15. So plug in the 32 for degrees Celsius. So we get Kelvin equals 32 degrees Celsius plus 273.15. That gives you a Kelvin of 305.15. Now let's move on to our final temperature conversion problem. This problem asks 235 Kelvin equals what in degrees Celsius and what in degrees Fahrenheit? So let's take our Kelvin equation. And for this one, we're going to want to subtract 273.15 from both sides. That will give us our degrees Celsius, which in this case is negative 38.15. Now that we have our Celsius, we can find our degrees Fahrenheit. Our degrees Fahrenheit equation is degrees Fahrenheit equals 9/5 times degrees Celsius plus 32. So plugging in the Celsius we just found, we got degrees Fahrenheit equals 9/5 times negative 38.15 degrees Celsius plus 32, which gives us degrees Fahrenheit equals negative 68.67 plus 32, which gives us degrees Fahrenheit of negative 36.67. Now we have solved our 4 practice problems with temperature conversions. Let's move on to heating degree days. Heating degree days help with agriculture and many other sectors. What you're going to want to do is first take the average of the maximum and minimum temperature for the day, and then subtract it from 65 degrees Fahrenheit. Let's try this heating degree day problem. Compute the number of heating degree days for a day when the maximum temperature was 60 degrees Fahrenheit and the minimum temperature was 39 degrees Fahrenheit. Following the NOAA and NWS practices, the mean daily temperature is rounded up to the nearest whole degree, if necessary, before calculating heating degree days or cooling degree days. So to start this problem, first take the average of the maximum and minimum temperature for the day. In this case, the maximum temperature was 60 degrees Fahrenheit and the minimum temperature was 39 degrees Fahrenheit. So remember our average equation from the first chapter? In this case, it will be maximum temperature plus minimum temperature over 2, 2 being the number of variables. You're going to want to plug in your maximum temperature and minimum temperature. So that gives you 60 degrees Fahrenheit plus 39 degrees Fahrenheit over 2. That will give you 99 degrees Fahrenheit over 2, which equals 49.5 degrees Fahrenheit. So now we're going to want to subtract 49.5 from 65 degrees Fahrenheit. 65 degrees Fahrenheit is a variable temperature given for heating degree days in the calculation given by the NOAA and NWS practices. But remember, 49.5 has to be rounded up to 50 degrees Fahrenheit. So now we have 65 degrees Fahrenheit minus 50 degrees Fahrenheit, and that will give you 15 degrees Fahrenheit. So now we have our final answer of 15 degrees Fahrenheit. This will be considered heating degree days because our average temperature that we found was 49.5, or rounded up to 50 degrees Fahrenheit. That was below 65 degrees Fahrenheit, so that will be considered heating degree days. Cooling degree days would be if our average temperature was above 65. You can check the math notes to find a cooling degree day problem if you would like to calculate it that way. Now let's move on to the Bowen ratio. The Bowen ratio is delta T, which is the change in temperature, equals Q over M times C. Q is the heat energy in calories, M is the mass in grams, and C is the specific heat in calories per degree Celsius. Let's take this Bowen ratio problem. Suppose the container has 800 grams of dry sand and 2,000 calories of heat energy is supplied, assuming no other sources or sinks of heat. The specific heat of dry sand is 0.188 calories per gram per Celsius degree. Assume the sand has an initial temperature of 5 degrees Celsius. What is the final temperature of the sand? First, when attempting one of these math problems, what you want to do is take out the variables. So in this case, Q, or the heat energy, is 2,000 calories. The mass is 800 grams, and C, the specific heat, is 0.188 calories over grams per degree Celsius. Let's plug our variables into the Bowen ratio. So to find the change in temperature, or delta T, it equals Q divided by M times C. Let's start with the bottom part, M times C. M times C equals 800 grams times 0.188 calories divided by grams times degrees Celsius. The grams are going to cancel because you have one on top and one on the bottom. So you have 800 times 0.188 calories over degrees Celsius. When you times across the 800 times 0.188, you get 150.4 calories divided by degrees Celsius, which equals 150.4 calories per degree Celsius. So now you can put the 150.4 calories per degree Celsius on the bottom of the equation. Now you can plug in Q on top, which is 2,000 calories. This will give you a change in temperature of 13.3 degrees Celsius. Now you are going to want to take that difference in temperature, or delta T, and add it to 5, which was our initial temperature, to get your answer. So our answer equals 5 degrees Celsius plus 13.3 degrees Celsius, which equals 18.3 degrees Celsius. For the fourth question in this video, review figure 4.17 on page 119. Note that to heat a 1 gram ice cube from a solid to a liquid requires 80 calories per gram. Read the section on latent heating found on pages 118 and 119. You have a large blob of ice that is 50 grams. How many calories of heat energy are required to melt those 50 grams? The ice is at 0 degrees Celsius. So you're going to want to take your 50 grams, which is the blob of ice you have, and times it by the change from solid to liquid, which is 80 calories per gram. So, since you have grams on the top and the bottom part of the equation, they cancel. So now you have 50 times 80 calories. So your answer is going to be 4,000 calories. Now for a follow-up question on heat energy. Evaporate that 50 gram blob of water at 0 degrees Celsius. How many calories of heat energy are required? So remember, to go from water to evaporation, you're going to need a different rate. The rate for that is 600 calories per gram. So now to set up your equation, it's going to be your 50 grams times 600 calories per gram. Since you have grams on the top and bottom part of the problem, you can cancel them out. So now you have 50 times 600 calories, which equals 30,000 calories as your final answer. A hint for question 5. Review the concept of the Bowen ratio on pages 120 and 121. Then turn to page 116 to think through the math skill question presented. Look to the last paragraph on the left-hand side and read about dry soil. This should help you complete question 5. This ends the Chapter 4 math video. As always, please let me know if you have any questions about the material. Have a great day.